Every number has its own special properties and characteristics. Today, I would like to share a property of number 121 and how it relates to one of the unsolvable problems in modern mathematics. This problem is called as Brocard's problem, and it was posted in the year 1870s, and it was also independently posted by Srinivasa Ramanujan, who is one of the world's famous mathematicians in the year 1930. So here's the problem statement. Does n factorial plus 1 equal to m square has any integer solutions except n equal to 4, 5 and 7. While this equation seemingly looks very simple, this particular problem is actually unsolved. And mathematicians have looked into the theory part, and also they have used and processed a billion digits of numbers using the latest available technology. So let's kind of like deep dive into this equation, and we will see how 121 plays a part in this. I'm going to rewrite the equation again. We have n factorial plus 1 equal to m square. So to understand this equation better, let us simply break down the available terms here. The first one is going to be n factorial. So for people who are new to factorial, it just states that n factorial is the multiplication of n until it reaches 1. So for example, 2 factorial is nothing but 2 into 1, and 3 factorial is nothing but 3 into 2 into 1, and let's say 7 factorial is 7 into 6 into 5 into all the way up until 1. Now we understand what the n factorial is. The next term is 1, which represents the number 1, and the plus represents, we are doing an addition of these two terms. Now let's look into the third term, which is m square. What I mean by the m square is this particular number needs to be a square. By square, I mean that it is a product of two numbers which is multiplied. So again, we have m into m. Again, some of the examples of these are 2 into 2 gives you 4, and where, so in this case m equal to 2 and m square equal to 4. 3 into 3 gives you 9, which means that m equal to 3 and m square equal to 9. The key term in our equation was we need to find where it is an integer value, right? So as you can see, not all the numbers fall into this particular square property. So we have 4, then we have 9, then we have 16, 25, and so on. So any number which is not follow these numbers will not satisfy this equation, because the key here is an integer value. Having understood the 3 different terms in this equation, let us go and try to solve some of them and try to find out how 121 relates to this equation. Just writing the equation again, m square. So to do this, let's try to walk through each step by step. I'm going to create a table which kind of like splits this equation. Okay, so let's say we have n here, okay, and we have n factorial, and we have the number 1, and we have n factorial plus 1, and then we have the m squared term. We can ask ourselves, is m squared a square? If yes, we can find the value of m, right? So let's start with the number 1. Okay, so if n is 1, n factorial is going to be 1 again, and we already have the term 1. We're just going to add 1 plus 1, which is going to give us 2, and m square is 2. Now the question is m square a square number? The answer is no. So for this particular value of n, this equation does not satisfy it. So let's come here, and so it is not a solution. In other words, we can tell this n equal to 1 is not a solution for this particular equation. Is solution. Okay. Now let's go to n equal to 2. Now n factorial is nothing but 2 into 1, which gives us 2, and we have the 1 term here, so 2 plus 1 gives us 3. Now m square is equal to 3. Now the question we need to ask is 3 a square number? The answer is no. Then again, this is not a solution as well. Now let's go where n is equal to 3. Again, this is 3 into 2 into 1. We have 6. We have 1 here. The total is 7. M square is 7. Is 7 a square number? The answer is no. Now let's go to number 4, where n is equal to 4. Now we have 4 into 3 into 2 into 1, which is 4 is at 12, 12 is at 24, plus 1, we are just following 1, and we have 24 plus 1, which gives us 20, and just retaining the 25 as m square. Is m square a square number? The answer is yes, it is a square number. And what it is? It is actually 5 into 5, so we can write m equal to 5, and there we have it. For this particular equation, when n equal to 4, this equation is satisfied. And there we have where n is equal to 4 and m is equal to 5. So we can write it here as the first set is 4 comma 5, where 4 is n and 5 is equal to n. Let's do for one more. We have 5 here. This is again 5 into 4 into 3 into 2 into 1, which gives us 20 into 6, 120, and we have 1, and we have 121 here. Again we have 121. Now 121 is a square number. Yes, it is a square number, and we have 11 here. Right? As you can see, this is where the 121 comes into play. So look at this. We have 2 does not satisfy, 3 does not satisfy, 7 does not satisfy, but 25 does, and 121 does. It is very simple, right? 121, 25, and 4 and 5. These are special numbers, right? Again, I can go here and write the key sets is going to be 5, 11, right? And yeah. The key thing we need to understand is 121 as being a square actually kind of like satisfies this equation. Let me go ahead and erase this. We have tried till 5. We can continue working on 6, 7, 8, 9, 10, and so on. But here is the interesting find. Okay, for 6, this particular equation does not satisfy because the m square is not a square number. Again, for 8, no. For 9, 10, again. But for 7, it does satisfy. So for 7, we have 7 into 6 into 5 up until 1, which actually gives us 5, 0, 4, 0, and we have 1, then we have 5, 0, 4, 1, and for m square, it is again m square is going to be 5, 0, 4, 1. Is m a square number? Yes, little complicated, but m actually tends to 71 square. So we have like another set of, we have 7 and we have 71. So we got n, and yeah, this is great. But look at this, in the first 10 tries, we have actually found 3 solution sets which satisfy this particular equation. All right. Now, the question mathematicians are asking is, what other numbers are there which satisfies this equation? So we can start with 10, we can go with 11, 12, and so on, maybe until 1000 also. And we need to do the math for each and every step and try to find, is m a square number? The question we need to ask is there any yes in this particular column for any of the numbers, right? So far, mathematicians have looked into billion of numbers, and the surprising fact is they have not been able to find one single solution set apart from these 3 numbers which we worked out. As you can see, this is an unsolved problem in mathematics right now. And people are not sure whether is there another set which kind of like exists, or only these 3 sets of numbers exist here. Let's look into the summary. For this particular equation, there are only three sets of integer values which satisfies this equation. They are 4, 5, and we have 125. So m, n, m, and m square. We have 5, then we have 11 and 121. Then we have 7, 5041, and we have 71. As you can see, for this particular equation, these are the only sets of numbers which satisfies this. So in the entire infinity of positive integers what we have, only these numbers are special, and that is why I believe this particular property is very special to number 120. I hope you enjoyed this video and it inspires you to learn more about numbers. Thank you for your time and hope you have a great time.